Hi all, welcome to this video on payouts, the responsibility of a good validator. This will be a two-part video. In this particular video, I'll give an overview of payouts and the automated payout applications available. In the second video, I will do a tutorial on installing one of these, which is Crunch. So the agenda is we look at payout basics, just to put everything into context. We look at some of these automated systems, and then we focus in on Crunch, and I will give my reasons why I selected this one for, a detailed review. So what is a payout? A payout is an event that issues staking rewards to nominators and the validator. It is actually available at the end of an era in which, there was some staking done. It can be initiated by anyone within 84 eras of its generation. So that anyone, I want to clear up a misconception. There is the belief that a payout can only be initiated by those who were party to the staking. That would be the validator or the active nominators. And that's not the case. This can be done by anyone whatsoever. The Polkadot.js interface has that limitation in which only the validator or the nominators can go to that payout section and see the payout. But if you go to the extrinsics, you can manually issue a payout for anyone. Okay, so I hope that clears that up. So what is 84 eras? Well, that's 21 days on Kusama or 84 days on Polkadot. Right? Now, payouts are not automated with any on-chain mechanism. It has to be triggered manually. So that is, once the era has completed, the payout is available. The chain doesn't automatically distribute the rewards. Someone needs to initiate it. It is manually triggered. So if the payout is not triggered within that 84 era time span, it is never written to the chain and it is lost forever. So those tokens are not generated. No one gets that reward. There is no undo there's no mechanism for actually making that payout. So it is lost. Okay. So it is customary for the validator to issue payments on behalf or issue that payout on behalf of the nominators. This is considered an administrative expense offset by the commission that the validator would receive. So the validator is receiving a commission as like a profit. So this is one of his expenses. With that said, some zero commission validators don't issue payouts at all. They leave it up to their nominators because they don't receive a commission. They don't receive a reward due to commission. To best manage payouts, many validators have implemented external automated payout applications. Now that external really means that it's not party to the chain, it's not developed by Parity, it's developed by members of the community to make things more efficient. And how does it do so? Well, I look at the last point. It reduces validators' manual interaction, and of course it makes for a good marketing point for the nominators. That last point really, as a validator, if you're managing your payouts manually, you need to check in on Kusama every 6 hours. If you miss that 6 hour time, your nominators would not get a regular payout. And something that nominators like is that at the end of every era, they look at their phone or their account and they see a payment. So it's a good thing if you're a validator that pays out regularly. And to do so, an automated system makes it very easy on you. All right. So when we're looking at for an automated system, what are some of the points that we should look at? Well, I think the first thing is whether the solution is open sourced. And this is important because this is a third party application running on your server. It is going to be interacting with a seed that has some funds, and you don't want someone to develop some application that takes some of your funds and transfers it out to their private account or something like that. So you need to have an appreciation of what is being done, and having an open source solution certainly helps. The second point is the developer reliable and an active part of the community. Well, that's quite important because of lending on the first point. You want to make sure that it's not an application that's malicious. And of course, you want continued development. So if they're active part of the community, they can continue making modifications and updating as the case may be. What are the dependencies? So there are some that run on the Node.js using Node.js, some that use Rust, some that use Python. It all depends on what you are comfortable with, and those dependencies being installed on your server, your actual validator server, or on a third-party server, an external server. The next point is, how is the payout triggered? So there are different options of triggering the payout. Some may trigger it automatically at the end of an era. Some may actually work as a cron job. So those are things that you need to consider. And the final is, does it support batch calls? Now this comes in handy if you are operating multiple validators or doing multiple payouts. If you're doing one payout at any point in time, then a batch of one and running one extrinsic one payout, it's like the same thing. So you really gain no benefit. So let's look at some options in context of all that I discussed. We have three. The first is Crunch. We have staking payouts, and then we have Substrate PayCTL. So the developer of, I'm going to look at each one individually. So if we look at Crunch is developed by TurboFlakes. It is reliable, and he is highly available. The platform is Rust. The run modes, it runs on a schedule, or it can be designed to pay out at the end of an era, and batch calls are supported. We have staking payouts, which was developed by Zeke. He's a developer in Parity. Of course, reliable guy. He is moderately available. Of course, he has his day job and his obligations there. This is built on Node. It runs on a schedule, so you need to use cron to run this every X time. Batch calls are supported. And then we have the Substrate PayCTL, developed by StakeLink. He's a reliable guy. He's also moderately available, not as active as he used to be. This is developed on Python. Like staking payouts, it runs on a schedule, so you need to use cron, and it will execute on whatever time that you set. And yes, batch calls are supported. So I see batch calls are supported by all of them now, which is good. And it's really like an evolution, because some of them did not start that way. I think StakeLink built that in with one of his first releases, which is rather cool. So I just have a note at the bottom that StakeLink has developed another tool, right, which is Substrate cron-D, and it allows jobs to be executed based on on-chain events. So you can manipulate or use this tool to run any one of those that I have run modes, run on schedule, to execute at the end of an era or the beginning of an era or something like that, right? But Crunch has that built in without the need for installing another tool. So I am going to highlight Crunch. I am actively using this one myself, and I would like to explain why I like it. One of the things that it has is that it integrates a button element so that I can also monitor whether payments were made, and I can actually view this on my mobile using the Element mobile app, and it will actually tell me that, okay, yes, payments were made, this is the amount of era points that I earned, and am I online in the next era, what's the mean era points. It gives a lot of stats, and I will show some details in the next slide. It also monitors the balance of the payment account and warns when it is too close to the existential deposit. So if the funds are running low, it signals me to top it up. And TurboFlakes himself, he is very accessible and supports his solutions well. So he actually monitors any nodes that are in the public element that are displaying their information there, and he will follow up with them if they're having any issues and get them onboarded quickly. So let's take a look at some of these this output information from Crunch. So to the left, we have a detailed bit of information for one validator, and on the right, there is a simple mode that just displays basic information, and I'm using that one for 6 validators. So as we can see, the detail gives you like the era points. It lets you know how many nominators, what's their percentage of the reward. It allows you to, it shows you like your inclusion and a lot more information, and all those links are relevant. So if you click on TurboFlakes, you get a Subscan link to your actual Subscan page, and if you click on the link for the block hash, you get to see that in Subscan as well, which is quite cool. If we look at the summarized version, it just gives you the essentials that you need. I am okay with that because what I'm doing, I'm actually processing a few extra payments, not only for myself, but my validators, but a few of the others as well. So as you can see, there's like Mile, myself, Vegas, and Bluefin Tuna. All right, so some requirements is that you will need to create an on-chain account and record the seed phrase. So this is actually where the funds are going to be to pay for the payout. So the extrinsic has a cost, and it needs to come from somewhere. And the second thing is that Crunch can use the public servers on Kusama or Polkadot, but I recommend using a local node, as I have observed connectivity issues to the public WebSocket RPC endpoint, and I have observed that there may be congestion on those servers. So really, using a local endpoint is very much advised. So on the point of advice, let's talk security. So the seed phrase for the payment account will be found on your server in a human readable format, right? It's going to be a file, and if you open the file, you're going to see a seed phrase for that particular account. It can be hidden, right? But that phrase, security by obscurity is not real security. So keep the funds on this account relatively low so it's not attractive to anyone who may want to attack your payout server and try to get that 2 2 or 3 Kusama that you put on it, right? So you just need to keep it low, or certainly above the existential deposit, and let Crunch monitor it and let you know when you're getting close to that existential deposit. So I put like 0.2 Kusama in it, and I put I think 2 dot, so I just did like a multiply by 10, sorry, for Polkadot. The WebSocket access is only required locally. Do not expose the WebSocket externally unless you have a special use case, right? So, just kind of limit your factors, and these are some of the things that you need to look out for. Perhaps, I mentioned it earlier when we were looking through at the points in terms of selecting the tool. See, don't just Google payout tools, and you need to make sure that these things are open sourced. You need to make sure you have an idea of who the developer is, because this is a third party application running on your server. You need to make sure that it is pristine and secure. Right? So that's about it, guys. I'm going to close out. The next video that's following is going to actually be an installation of Crunch. So I do hope you enjoyed that video and it helps you set up one of your own. Don't forget the prereqs. You would want to have that done before you go into the next video. Take care. Bye.